Welcome to my video on the composition of functions. This is lesson number 14 in my calculus tutorial series. So first of all, let's look at what is the composition of a function. Okay, what this is notation is f, and it's a little circle, and g, so that's the composition of two functions. And really what it is, you're inserting one function inside of another function. So g is called the inner function, and f is called the outer function. So you're just inserting one function inside of another one. And so this is going to be in preparation for our next topic, which is going to be on the chain rule of differentiation. So first of all, we need to understand what the composition of functions mean to compose one side of another. Simplest way, just do an example. That kind of illustrates the point here. So let's let f of x be equal to x squared and g of x be equal to x plus 1. So then we want to find the composition of f and g. That's what we're looking for. Okay, so f and g composition is going to be just equal to f with g of x inserted. Okay, our g of x is x plus 1, so this is going to be equal to x plus 1 quantity squared. So essentially we just substituted this g right in terms of that x. And so it's x plus 1 quantity squared. And now if we FOIL that out, we're going to get first outer inner last. There's a video on that. 2x plus 1. So that's just expanding it out. So there's our answer. Now let's do the opposite case here. Let's just look at g, the composition of g with f together. Now we're doing it in reverse order. So now let's look at this. So we get our, in this case, f of x squared is our g. So we got x squared plus 1 is going to be, because this becomes our, we've just switched the relationship of g and f. So the g now becomes x squared, and then we insert x plus 1 into that. And so what we see here is this is going to be our g, the composition of f. Now what we can see for this in general, it's not always true, because you can find cases where it is true. A simple example. So the composition of g, f and g does not always equal the composition of g with f. So that's something you want to keep in mind. Now let's look at another example. F of x is equal to x squared plus 3. G of x is equal to 2x plus 1. And let's find the composition. So we want to find f with g of x inserted in there in place of the f. So now our f of x is x squared, so we've got 2x plus 1 quantity squared plus 3. Multiplying that all out, squaring the 2x plus 1 is going to give us 4x squared. That's the first term, plus 2x plus 2x plus 1. And then we're going to add the plus 3. So there is our, it looks like it's a quadratic. So combining like terms, plus 4x plus 4. So there is the composition of these two functions, f and g. So like I said, this is a preliminary for getting us into the chain rule of differentiation. We need first to understand if we stick one function inside of another one called the composition. Well, I hope you got something out of this video and learn a little bit about the composition of functions, and we'll see this again. Well, thank you for watching, and also leave me any comments if you've got any questions or issues. Thank you. Bye.